All right, welcome to the last CS 101 lecture section. There's not going to be exercises for this section. I'm just going to try and, summarize what it all means and talk about some next steps. So for CS 101, I took the strategy of just jumping right in with code, really, and we got into the details of code and played with code, and my plan was that as you played with code and had bugs and experimented, that you would gradually just come to see what some of the features are of the computer. So I hope that worked. Today I'm gonna step back and talk a little bit about what it means and some terminology and things. So first thing I want to talk about is this word algorithm I may have used here and there. Algorithm, actually, it's named after a Baghdad astronomer, Al-Khwarizmi, whose name also, some of his work ends up in the word algebra, so he's rather influential. So the idea of an algorithm refers to the steps to take to get something done. So not just saying, well, I want this curve to be blue. That's just saying what the goal is. The algorithm is really figuring out how to solve something and describing what the steps are. Now, that's not the same as a syntax. Syntax is really a computer language feature. So algorithms, I would say, capture really human creativity of how am I going to solve something. And really for CS 101, very often for the exercises or in the lecture examples, I've been describing an algorithm. Oh, take the pixel and do this and do that, whatever, describing what the steps are going to be, and then I've left it to you to then phrase it into code. And that's just a totally classic computer system way to work. You have the human, they have the idea, and eventually it gets phrased into code. And I'll have a bunch of examples today that sort of hit that pattern. So just as an example, I won't go into the details exactly, but here's the code from the monkey moon example. And so we had this strategy of like, compute the average, and then try and find the blue background behind the monkey, and then copy the red, green, and blue pixels values over. So what's interesting is that's the idea, which was pretty complicated and effective, and then here it is expressed into code. And partly, it's a little bit amazing that we did. That code's fairly complicated, right? So at least a couple weeks ago, you didn't understand this. So it also shows the gap where we had this plan, what we're going to do, but then look at the individual steps in the code. Pixel.getRed, average time 0.92. The building blocks that the computer has are really pretty simple, right? Just get red. There's no insight. It's just mechanical. And then in a way, this gets at what a computer programmer does, right? Take an idea that's interesting and valuable and sort of phrase it down to the computer, break it down into the little mechanical steps that the computer can do to sort of build up the program that we really want. And that's a key example. That's what the modern world looks like in terms of the computers doing useful stuff. So as long as I'm talking about code, having an algorithm and phrasing it into code, I also thought I could revisit the word bug. I'm sure this is a word you've all heard at one time or another. Here's a little example of a bug where I have the for loop over the image. And then here, imagine I'm trying to change an image to gray. And so I could have the line average equals pixel.getRed plus getGreen plus getBlue /3. The problem here, this code does something. It just doesn't compute the average as I intended. The problem here is that the /3 only applies to the getBlue. We would need to put parentheses in here to make it work right. So the result is that one's divided by 3, these aren't, and so the number's going to come up to like 450, just way too big. And so setting it into the image makes the image come out almost near white. That's just an example of a bug where there was an intent. Well, here's the algorithm I want to do, but the code I typed in said something else. It said something. It had steps the computer could follow, but it wasn't the ones I intended. And that's very often what bugs look like, and I'm sure you've probably run into bugs all the time. So there's a little insight of where the gap was between the intent of the programmer and writing out the steps for the computer to actually do. So the sort of connection I'm talking about is, right, at the very start of the class, I'd made this kind of provocative claim. Well, computer equals powerful plus stupid. The computer's so stupid and limited, and I stand behind that. I think you have seen the computer has these limitations. And yet, they're obviously very useful. We have email and the internet and computer games, all this phenomenally valuable, awesome, useful stuff. So how did that work? And I guess ultimately the answer is humans. That a human programmer had a creative, an idea of like, here's what I'm going to do, and this is going to be great. And that's really that's what computer programming are. That's what computer programmers are, and that's what computer science is about. And then it gets broken out of these steps so that the computer can actually do it. So I just have some examples here. Grab some of these from Stanford. So these are examples where you have the computer just following its mechanical steps, but doing something that I thought was kind of impressive. So Daphne Kohler at Stanford has this awesome research on grading cancer cells. So basically you have a Petri dish with some sample cells in it, and you show a computer an image of it, and then the computer is going to, eventually she trained the computer to do grading, so something that normally humans do that's actually pretty difficult, and humans have a tough time doing a good job of it. And so what I want to get at is, this looks a little bit like our image code. It's not that you just say to the computer, hey, I want you to grade these. Really, the computer just has RGB values, or whatever, a bunch of numbers, and can do less than, greater than, and loops. So those are the building blocks, and so it required real ingenuity to phrase up an algorithm for the computer using its simple abilities to do something profoundly useful, like grading cancer cells. So I'm just putting links here for if people want to visit the document, and they could try those out. Another example that's just sort of amazing is there's a treatment for certain forms of deafness called a cochlear implant. And there's a little bit of controversy in the deaf community about if this is a good idea or not, but it is amazing. The way it works is there's a microphone that takes in sound, and the sound waves, kind of like we saw in the analog digital lectures, are processed by a computer and eventually ultimately end up with going into wires that go directly into the hearing, the sense organ in the head. And so it's possible to give, not exactly hearing, but a sort of hearing for someone who was potentially completely deaf before. So there's, I gotta say, a fairly amazing video, YouTube video clip here of a baby hearing their mother's voice for the first time, and so it's worth seeing if you're curious about that. I gotta say, if I was an engineer who had anything to do with this project, I would be very proud. Like, that is it's such a vivid example of a technology really changing someone's life. Last example, also poached from Stanford, is this idea of the self-driving car. So this involved, the car has all sorts of cameras and rangefinders on it, and it's sort of, I put in quotes, it's kind of seeing its surroundings and trying to understand what the obstacles and pedestrians, whatever, are, and then making decisions in real time, right? It has to decide right now what to do. That's a profoundly hard problem. So Sebastian Thrun at Stanford, and now working on this at Google, has made a lot of progress with this. And I gotta say, I'm sort of a natural optimist, but I think this is totally gonna happen. I think it's gonna happen because although the technological challenges are enormous, ultimately it'll save time. And as society becomes more wealthy, time is just something everyone values. And I think that's going to provide a lot of pressure to make this work. So I'll be interested to live long enough to see that working. All right, so I want to talk a little bit about post CS 101, things you might want to think about. So most people are not going to be computer programmers. That's fine. We need more, but certainly it's not for everyone. So I think there is kind of a skill to just working with computers. Computers obviously have this sort of mechanical, slightly fragile, everything has to be just so way that they are. And my hope is that with CS 101, you've seen how that is enough times and in different ways that it's given you a little bit of confidence and a little bit of patience. I think sometimes people do something with a computer and they click the button and it doesn't do what it's supposed to, and then they're sort of stuck. They're like, well, what do I do now? And they can't get past that step. Whereas now I think you've seen the kind of mechanical quality of the computer. My hope is that you have a little patience to say, okay, well, it's not doing what it's supposed to. Let me read the docs again. It's probably just some little dumb thing, right? Like a missing semicolon or whatever, some little detail that computers get tripped up by. And so I think there is a skill to not getting derailed when the computer messes up like that. And I'd like to think that CS101 helps give you that skill a little bit. It's certainly a very handy life skill since computers are everywhere. So finally, let me list off classes or whatever, things you might want to study after CS101. I have bad news about this. There is not a class which I think is really a good fit to just be right after CS101. There just isn't one that I know of, so I'm not going to recommend a specific one, but there's a lot of research and activity in that area. Someday, maybe, hopefully I'll create one, but I haven't done it yet. So I'm just going to mention things that you could look at, I think, sort of from a post-CS101 point of view. So one thing I'll mention is spreadsheets. Spreadsheets are very commonly used to organize data or do little computations or whatever. You may probably heard of them. So the next time you see a problem where someone says, oh, hey, we could do a spreadsheet for this, I'd say you might want, you could consider, you might take a shot at that. The sort of quote-unquote programming in spreadsheets is not that different from what we've done. Microsoft Excel is a super popular spreadsheet, but it's not free. The Google Docs spreadsheet is free, and actually it uses JavaScript, which is the language we've been using. So it's just, I guess, sort of a question of confidence in being open. Like, be open to reading the docs and reading some examples and trying to use that. A spreadsheet, I think, would not be much of a jump from what we've done, and they're very common, very commonly used for problems like that. So another next step is to take a sort of your general college introduction to programming course. A lot of colleges have this. I think some high schools do. So CS 101 is not a general programming course. I had the analogy somewhere that it's as if there's this island and it has 100 miles of trails on it, which represent all the different types of programming you might want to do. And in a way, what I've done with CS 101 is I've very carefully chosen 15 miles of trail. So I've showed you, you have seen real programming issues. You definitely have a sense of what bugs are, what loops are. I mean, those are absolutely vital core programming constructs, and you've done them. Like, you're legit. However, there's the 85 other miles. There's all sorts of stuff I didn't talk about. And I sort of constructed my examples and the way the lectures worked to just carefully use the things I talked about and not try and get distracted by all the stuff I didn't talk about. So you should just know that's kind of where CS 101 leaves you versus a regular programming course. Now, in a way, you have a nice head start. You've seen all this computer stuff. You've seen loops or whatever. So I think you'd have a bit of a tailwind going into a general programming course. You would expect it to move faster than CS 101. I tried to keep CS 101 at a pretty measured, hey, anybody can do this. I don't want it to be a stressful experience. So you would expect a bump up in the speed, but certainly something I'm sure many of you would enjoy doing. So something to think about. I'm just going to mention a couple other sort of specific types of programming that people have talked about. So HTML5 refers to web page programming. That's done with HTML, JavaScript, and CSS. We've done JavaScript in CS1, but I got to tell you, the JavaScript for web pages is going to look more complicated and have more going on. We did this very stripped down, very focused type of JavaScript. So for a lot of these kind of topics I'm going to mention here, the conventional college student way to think about it is that you would take the general programming course to just sort of get general loop, if statement sort of experience, to have sort of generic ability, and then you would maybe specialize and learn about web pages or something. It happens, web programming is not that hard, and so it's possible to just skip into web programming, like just have a HTML5 whatever course and just learn the JavaScript in the context of that. So other than that, I've gotten questions about sort of various areas, and I find it hard to identify any one in particular. I said, oh yeah, there's phone programming, game programming, finance programming, science programming, ... What I can tell you is it's a huge field. There's science, aerodynamics, finance. I mean, anything you could mention, there's computers going on, and generally it's regarded tends to be a shortage of people, and so if you are curious about computers, if you learn about computers and you want to work in that area, there's a good chance that you could. There is demand for people who know that stuff. So I guess I have to sort of summarize the course here. So my claim at the very start of the class was CS 101 teaches the essential qualities of computers by playing with code. You've certainly played with a lot of code at this point, so I hope that sort of holds up. My fear is that people go through life, they use computers all the time, but they see the computer sort of opaque and not comprehensible, something they could never understand. And I hope I broke that down, that you can sort of see through the other side and appreciate, computers work in this way and they're not good at this other thing, whatever. So just sort of put it in context, how computers work in your life. So as I said before, I also hope that with that knowledge, CS101 gives everyone a little bit of confidence and maybe a little bit of patience to work with computers and kind of get computers to work for them. They are, as I've always said, they are stupid and mechanical, but they're also incredibly useful. All right, take care.